So hey guys, welcome to our first vlog. I am Reka, together with my group mates Mr. Tapnio and Miss Gutierrez. And today, we're going to take you behind the scenes of our experiment number one, which is familiarization of fluids and hydraulic equipments. If you've ever wondered what kind of tools engineers use when studying how water moves or how pressure works, then this one's for you guys. So this is our group. I, Reka Desena, Aljon Tapnio, and Ian Gutierrez. Ay, sorry. Hmm. So basically, this experiment was all about getting to know the different laboratory equipments used in fluid mechanics and hydraulics, their names, their functions, and how they actually help us understand the behavior of fluids. So let's start with our objectives. Our main goal was to familiarize ourselves with the common hydraulic and fluid mechanics laboratory equipment and to understand their functions and applications. And after doing this experiment, we should be able to explain their basic uses and operations, identify which equipment is used for which purpose. So basically, this experiment was our first step to becoming more confident and careful in the laboratory. Familiarization is very important before performing any actual experiments. By being familiar with the structure and purpose of each apparatus, we can operate them safely, avoid errors or accidents, and collect accurate data in the future laboratory activities. Hmm. So for this experiment, we used simple materials such as equipment pictures for identification, pen and paper, and then coloring materials for documentation, and that's all. The procedure was carried out in five parts. Procedure 1, orientation on safety and lab rules. Procedure 2, instructor demonstration of equipment. Procedure 3, group familiarization and documentation. Procedure 4, research and description and uses. And then procedure 5, preparation of group experiment paper. So, this systematic approach ensured that everyone in the group participated actively and learned the proper use of each devices. So for our data and results, this is our drawings and their functions. So for our first lab equipment, the teaching flume demonstrates open channel flow principles. It is a transparent, long equipment, usually between 2.5 to 5 meters, that allows us to clearly observe water flow behavior. This device helps us visualize phenomena such as flow rate, turbulence, hydraulic jumps, and surface profiles. It's particularly useful in civil engineering when analyzing river flow or canal designs. Next, we have hydrostatic pressure apparatus. It is used to determine the static thrust exerted by a fluid on a submerged surface. It consists of transparent rectangular water tank and a counterweight system for precise measurement. Through this apparatus, we can better understand how pressure acts on surface at various depths, which is fundamental in designing dams, tanks, and underwater structures. Next, we have beaker. It is a simple yet essential laboratory tool. It's a cylindrical glass container with a flat bottom and a small spout for easy pouring. So beakers are mainly used for holding, mixing, or heating fluid examples. Even though it seems basic, it's a key part of nearly every experiment because it serves as our main container for handling liquids safely. Next, we have Bernoulli's theorem apparatus. It illustrates one of the most important principles in fluid mechanics. It is the Bernoulli's principle. This principle explains the relationship between velocity, pressure, and elevation in a moving fluid. The apparatus features tubes of varying diameters and piezometer tubes that showed pressure differences along the flow. It helps visualize how energy conservation applies in fluids, a concept vital in designing pipes, pumps, and turbines. Next, the U-tube manometer is used to measure pressure differences between 2 points in a fluid. It's a U-shaped glass tube, particularly or partially filled with liquid and mounted on a stand for easy reading. By observing the height difference between the two arms, we can calculate the pressure changes. A simply yet accurate method that remains widely used in laboratories and industrial systems. The vortex flow apparatus helps us study free and forced vortex flow. It has a transparent circular tank with adjustable inlet and outlet openings that let us see the swirling patterns of water. This device allows us to understand the rational motion of fluids, which can be observed in a natural phenomena like whirlpools, tornadoes, and even in industrial processes like mixing and draining systems. Lastly, the weighing scale is used to measure the mass of fluids or other materials accurately. It can be either digital or mechanical. In fluid mechanics, knowing the exact mass is crucial for density, volume, and flow rate calculations. This ensures precision in our data, especially when working with experiments that require accurate fluid measurements. For our conclusion, to conclude, this experiment was an essential introduction to the world of fluid mechanics and hydraulics. It enhanced our understanding of various hydraulic instruments and their real-world applications. Through hands-on exposure, we gained practical experience that improved both our comprehension and laboratory efficiency. As future engineers, we now recognize the importance of accuracy, observation, and experimentation, qualities that are vital in designing and maintaining hydraulic systems. For our references, we used several reliable sources such as these. These references supported our understanding of the theoretical principles behind the equipment we studied. So that includes concludes our presentation on experiment number one, familiarization of fluids and hydraulic equipments. Thank you for listening, and we hope you learned more about how hydraulic tools play a crucial role in engineering applications.